we're going to work with ratios. So ratios are really just a fancy way of asking you to write a fraction. The ratio of A to B, so A to B, can be expressed in a couple ways. A to B like that, or equivalently, which is what I mean by this bidirectional arrow. A colon B, or yet one more time, A divided by B. Now the order here matters. A to B means A is going to be in the numerator and B is going to be in the denominator. Let's start with problem number 18. They asked us to form a ratio between 2 miles and 9 miles. So what's the ratio of these two? Well, A over B, that's going to be 2 miles over 9 miles, like that. Hopefully, though, you don't give me this as a final answer. Is there any simplification I can do? Does anyone see anything? Units of miles will cancel out because it's the same in both the numerator and denominator. So you're just left with 2 over 9. So it doesn't matter if you started out with 2 feet to 9 feet or 2 boats to 9 boats, etc. The ratio is going to simplify to 2 to 9. Now it was nice that we had the same units in both the numerator and denominator. That's what allowed us to cancel. If we don't, then we're going to have to work to get that. Let's look at problem number 26. 6 feet to 12 yards. Well, if I just form my ratio, 6 feet over 12 yards, I can't really do the cancellation here, can I? The units in the numerator and the units in the denominator aren't the same. So what I would suggest is you convert to the smaller unit. Which is the smaller unit in this case, feet or yards? Feet. Now, I'm not going to make you a master of all kinds of useless trivia that you can look up on the internet at any one time. Any conversion that you would need, I will give to you on an exam. Like 1 yard is 3 feet. We're going to use this to convert units of yards to feet. Now, on the test you got back the other day, one of the problems was to convert by multiplying by 1. And this is what I was implying. If you have 12 yards and I want to convert that to feet, I can do so by multiplying by 1 in the proper form. So if I want to get rid of the units of yards, I'll put that in the denominator, 1 yard. 1 yard is 3 feet. As strange as it may seem, this is a fancy way to write the number 1. 3 feet is 1 yard. So that's multiplying by 1. But in this case, because I put the units of yards, the units that I want to cancel are on the bottom, I can get rid of those. 12 yards is how many feet? Good. 12 times 3 is 36, and the units would be feet. So 36 feet. I can rewrite this ratio then. Instead of 6 feet over 12 yards, let's now write it as 6 feet over 36 feet. And see if that helps us out. We any better off now? I hope so. Maddie, what kind of simplification do I get here? Good. So units of feet is going to cancel. And hopefully you're not content with this because 6 goes into 6 once and into 36 6 times. So 1 over 6. Nice. Let's try another one like that. It's going to be problem number 24. Are we okay with problem 26 here? All right. Why don't you try problem number 24? This time we want to convert 20 inches. Actually, we don't want to convert. We want to compare 20 inches to 2 feet. 20 inches compared to 2 feet. Well, let me helpfully remind you that 1 foot has 12 inches. What's the smaller unit here? Inches. So am I going to convert to inches or am I going to convert to feet? Convert to inches. 2 feet. Convert that to inches. Do the conversion, then see if you can't simplify from there. As before, help each other out if you're stuck. I'll try and walk around. All right, so if I'm going to convert to the smaller unit, then we're going to take 2 feet and multiply it by something that's going to cancel with feet. 1 foot has 12 inches. So I'm going to get some cancellation here. Units of feet will cancel. 2 times 12 is 24. And the units that I'm left with are inches. So inches. I can replace 2 feet by 24 inches. So this is going to be the ratio of 20 inches to 24 inches. And now when I form that ratio, putting this in the numerator and this in the denominator, I can get the units to cancel each other out. So that's good. That's what I was hoping to happen. 20 divided by 24 reduces to 5/6. Yay. How many got that one? All right, good deal, good deal. Now this is just a ratio. Ratios are powerful in and of themselves. I showed you a few examples before we started rolling video here. But where they're really powerful is when they are part of a proportion. So let's talk about proportions. Proportions. Okay, so a proportion is when you have 2 ratios that are equal. So one fraction equals another. That's a proportion. Now, if that's true, that you have these 2 things equal, then something else is true. That is, A times D equals B times C. Their cross product is equal. That's going to get a lot of work done for us. Now, we're first going to start out by figuring out whether or not things are in proportion. So we'll do an example here. Problem number 30 is 7/16 a proportion with 3/7. Well, if this was in proportion, then we can cross multiply 7 times 7 and get the same thing we do when we do 16 times 3. Since 49 doesn't equal 48, this is not a proportion. Cool. Let's try another one. Problem 32. 9/32 is at a proportion. Now the question mark's my own. The book doesn't write that. Is that in proportion with 4.5/16. So do the same thing that we did with the last one. That is, cross multiply. While you do that, I want to take a quick peek at something here. So that should be 9 times 16. Is that equal to 32 times 4.5? So 9 times 16 is 144. 32 times 4.5 is also 144. So it checks. Just a quick side note here. In terms of proportions, we talked a little bit about aspect ratio. Suppose you had a file on your phone. You took a little picture of maybe a deer that you saw passing into work today, and the file size was 768 by 1024. And you're like, oh, that's cool. You know, I got a nice frame at home. I wonder if I blew that up and put it in a frame if it would fit. What's a typical frame size? 8 by 10? All right, 8 by 10. So 8 by 10. Is this a proportion? Let's find out. 768 over 1024. Does that equal 8 over 10? In other words, if I blew this up, would it fit, or would I have to crop it somehow? It's a good question. So 768 times 10, 8 times 1024. Do I need a calculator to determine these are equal or not? They can't be, right? This would end in an 80, and this would end in, something with a 2. So it's not a proportional. Basically, if you wanted to use this frame, you'd have to crop your photo somehow or another in order to make it fit. You wouldn't get the whole image. Where proportions become even more powerful is when you start working with variables. Let's see that with problem number 36. 27 over x equals 9 over 4. Same thing as before. We're going to work with this by cross multiplying. We can do that because this is a proportion. You have one fraction equals another fraction. 4 times 27 equals 9 times x. Somebody have to check me on this. 4 times 27 is 108. Divide both sides by 9, and I think you're going to get 12. Beautiful. So 12 would make this a proportion. You can see that if you go back and check it. 27 over 12, well, that's not in lowest terms. You can divide both the numerator and denominator by 3. And if you do so, you get 9 over 4. Okay. So basically what we're saying is that 27 over 12 is the same thing as 9 over 4. Yeah, that works. You don't have to check your answers in these types of problems. I'm hoping you're not going to get a 0 there. But it's not a bad idea. It's in section 7.6 that you have to check your answers. Let's try problem number 38. X minus 1 over 7 equals 2 over 21. Now just a little piece of advice here. If you're working one like this, put parentheses around that numerator term for yourself. Now chances are on an exam or in the book, you're not going to see those there. But it's helpful for you. We're going to get 21 times x minus 1 and 7 times 2. The reason I want those parentheses is because I want you to distribute that 21. 21x minus 21 equals 14. And what from there? Add 21 to both sides. Divide both sides by 21. And I hope you don't leave the answer like this. I'd be stuck in a little quandary. I'd be like, yeah, what should I do? What's wrong with this? It's not in lowest terms. Perfect. So I can divide both the numerator and denominator by 7 and end up with 5 over 3. That's in lowest terms. I mean, not that it's a real big deal if you fail to see that, but I would like it in lowest terms. How are we looking at problem 38? Because I'm going to give you one that's going to be similar to that. I want you to try problem number 44. 3x over 16 equals x plus 2 over 5. This one's all yours. And I'm going to take a moment and see if I can't open up a different file. But copy this down if you would. And then I'm going to switch screens. Rats. All right, looking good. So if we cross multiply, it's going to be 5 times 3x equals 16 times x plus 2. And again, maybe you want to put parentheses around this, that you make sure you distribute the 16 to both terms. 15x equals 16x plus 32. Now, a couple different ways you could solve this one. Personally, I like the idea of moving this to the side with the largest coefficient. So I'll subtract 15x on both sides. That gives me 0 equals x plus 32. Since I've got my x on one side, I'm going to put the constant on the other side. So I'll subtract 32 from both sides. End up with negative 32 equals x. The other way you could have done this is subtract 16x from both sides. Then you'd end up dividing by negative 1 to finish solving. That works as well. But how we do on problem 44? Okay there? All right. Now, I couldn't find it. I was looking for it as you were working on this one. But I used to have an old extra credit assignment that talked about the relative size of the solar system. And what I did was I put the sun... 10 minutes? Yeah. That'll be all done for the day. Thanks. So I put the sun at the goal line and the earth at the 2-yard line. Now in this scale, if the earth was at the 2-yard line, any idea how far Pluto would be away from a touchdown? A long ways. 79 yards. It's a long ways out there. It's way out there. Yeah, it's once you leave the atmosphere, space is very appropriately named. There's a lot of space out there. There's not a lot of stuff. So let's think about it this way. Um, the Earth, let's see, it's 2 yards compares to 79 yards, as the Earth, the distance from the Earth, compares to the distance from Pluto to the Sun. Distance from the Earth to the Sun is 93 million miles. At this scale, how far away is Pluto? So there's your equation. Now we can dispense with the units, but 2 over 79 equals 93 million over x. See if you can't figure out how far away Pluto is. Yeah, so you might want to dig out your calculator on this one. What'd you get for x? A really big number, yeah. 3 billion, keep going. Well done. So this is the average distance of Pluto from the Sun, is about 3.6 billion miles. It's a long, long ways. In fact, the speed of light is 186,000 miles per second, and it would take light. The light from the Sun doesn't reach Pluto for about 5.5 hours. It takes 5.5 hours at 186,000 miles per second for the light from the Sun to reach Pluto. Wow, way out there. Let's do problem number 68. And I want to go back and kind of compare and contrast this with stuff that we did in section 7.6. So this will be our last one. We are going to make the most out of it, though. So it's going to be 2 over 4d minus 1. Sorry about that. It's just a little typo. 2 over 4d minus 1 equals 3 over 2d plus 1. Now, if we approach this from the point of view of what we did in section 7.6, you start out by looking at this and saying, okay, well, I've got this as a denominator and this as a denominator. I'm going to start by multiplying both sides by the LCD. The LCD for this equation is really just going to be the product of both of these things, right? It's going to be 4d minus 1 times 2d plus 1. I'll do that on the left-hand side as well. 4d minus 1 times 2d plus 1. What's going to happen when I multiply both sides by that LCD? Those cancel each other out, and these cancel each other out. And yes, Preston, this is the same thing we would have gotten just a minute ago by cross-multiplying. 2 times 2d plus 1 equals 3 times 4d minus 1. But this is kind of a justification of why we can do the cross multiplication. So that's why I did it. I do want to note, though, that this only works if you have one fraction equals another. Now in section 7.6, you can't do that. This is not one fraction equals another. You can't multiply, you can't cross multiply here. If it was something like this, where you have one fraction equals another, you can cross multiply, but not like this. So only cross multiply when you have two ratios that are equal to each other. In other words, a proportion. To finish this up, that's 4d plus 2 equals 12d minus 3. I'll move the d's to the right-hand side. 2 equals 8d minus 3. Once I've got the constants on the left-hand side, I'll divide both sides by 8 and get 5/8 is d. Did I make a mistake there at the end? Yeah, no, that's right. That's right. Okay, I'm looking good. Yeah. Any other comments or thoughts on 68 here? For homework. Let's see. Try 17 through 49 and 53 through 63.